Exercise 10F question number 1. Two particles A and B are mass 4 kg and 3 kg respectively are connected to light inaccessible string. Pass over the small pulley. So this is, we'll take this 3 kg. This is 4 kg. We'll consider this the weight of this one is 4g and this is weight of this one is 3g. So now there is a tension and that's how we mark the tension as usual. This is also a tension, we'll put that F. Now the first question is find the tension. Now when we release from the rest this system, we can see that to our sense that this particle has more weight, then it is accelerate towards here. Let's say that acceleration is A and this acceleration is A upward. It has to be, it should be, the magnitude should be the same. So for particle this is A and this is B. For particle B, F equal ma to upward. So we will get that, we'll take this tension as T minus, so I'm considering this particle, T minus 3g equal, m is 3 and A will take as A. Then for particle A to downward, F equal ma to downward. Then there are two forces for this one. One is T and 4g. So 4g is positive and then T is negative. And the mass is, we know now it is 4 and we took acceleration as A. So then this is A. Now we have two unknowns T and A. So we have two equations. This is 1 and this is 2. We can solve. We can find A and T together. So the question is find the tension. Yeah, from here I can make A as a subject and I can find the tension. But when I look at the other side, part B, find the speed of A when hits the ground, then I need to find A. So better to find T and A in the same now. So 1 plus 2, when we add those two together, 4g minus 3g equal 3a plus 4a. So this is going to be g equals 7a. So a equal g divided by 7. Now we found out the acceleration. Now we need the t. So from we'll go to the from 1, t equal 3g plus 3a. So t equal 3g plus 3 times a is g divided by 7. So this is 21 plus 21g plus 3g over 7. So 24g over 7 is the tension. So this is going to be 33.6 Newton to 2 SF. Now, when A travel a distance of 2 meters, strike the ground and immediately come to rest. So ground is here. So from when it is rest, u equals 0 at this point, and this height is going to be 2 meters. So when this particle travel 2 meters, it hits here. We need to find the speed of when hits the ground. So A come like this and it will hit the grounds. So we need to find the speed V when it's hitting the ground. So we know S equal 2 meter. We know A equal G over 7. And what else we know? We know U equals 0. It is starting from rest. Then V square equal U square plus 2AS. S mean V square minus U square divided by 2A. So V square, sorry, actually we need to find V square, not the S. So we have to leave as it is. So we can find now U square 0 square plus 2 times A is G divided by 7 and S is we know 2 meter. So this is V square equal 4G over 7. So V equal square root of 4G over 7. So the speed is 2.3664. Now this is the time that this A particle come and hit the flow. So when it is hitting flow, we know that V is 4G over 7. So at the same time, the same speed has the particle B to upward. So that is 4G over 7. At the time it's hit, what will happen? The tension is no more there because the tension is become 0. And what will happen is still this one has the speed to upward. Now this will move up to something like this, go up and then come back again and bring the make the tension again. Basically, since we have 4G7 upward, so this particle is moving somewhere here until this speed get 0. Let's say this V. So V is 0. So the one starting speed is 4G. We can think about for that journey. So starting from 4G7, under gravity, it will move up from here to here and it will stop. Then again it will fall under gravity. So the sum is asking, assuming B does not hit the pulley, find the greatest height that B reached above the initial position. So this is the height. So from the initial position. So initial position is here. It means from here to here 2 meter move because this distance is 2 meter. So when it come to here, this will move 2 meter up. So now it is here. From here, it will go freely until we get the speed equal 0. Now we want to find this distance. Then the total distance is, so this is 2 and we need to find distance. So addition of those two. Then for B, upward, I am going to put for this journey. For B, V square equal U square plus 2AS upward. Now we know that V is 0 and U is going to be starting one is the hitting one. When the same, this is square root, the same speed it is moving upward when it hits. So U is 4G over 7. it means square root u square is 4g over u square is 4g over 7. And A is now under gravity because there is no acceleration anymore. It is move under gravitational force upward. So this is going to be minus g because we are putting upward. The g is downward. Now from this one, v square mean 0 square. Now u square we have 4g over 7 and plus 2 times acceleration is minus g, it is go under gravitational force. Now we have the s. So s equal so 2gs equal 4g over 7. So g to g cancel out. S equal 2 over 7. So this distance we found out because s to s also cancel out. G to G cancel out. This is 2 and this is 2. So 2 over 7 meter. And this length is 2 meter from here to here until it's hit. So the total length is 2 plus 2 over 7. So I draw this one again to show that. So when v equals 0, you can see this kind of setup. The string is like this. It's no more taut and so this is now under gravity, and at this point v equal 0, and then it will start falling back. So there is no continuation of this sum. So we managed to find the this height. This is starting speed. This we took the square root u 4g over 7 from here, and yeah, and we work out. Question number 2. So two particles hanging. One is km and other one is 3m. So there is this is 3mg weight and this is kmg weight, and this is tension and this is tension. This is a smooth pulley. The tension is same everywhere. Now which one is heavier, km or 3m? They give guidelines k less than 3, so then 3m is heavier. Then we are expecting when it's released, it's coming to this direction, and the speed is given, the acceleration is given 1 over third g ms minus 2. This direction, it means it's more, it has the same direction to upward, 1 over third g ms minus 2 to this particle. So this is p particle name, and this is q particle. And why they have both same acceleration? This is downward and this is upward because the magnitude is same, because the tension, this is a inextensible string as well as a smooth pulley. Now when we have this setup, we have only two equation. One is f equal ma to upward and other one is downward. This is standard. So we have to always put this one. Sometime okay, we'll start f equal ma to consider particle q. So when you consider q, you get to downward f equal ma. So 3 mg positive, 2 force, the tension is negative the other way around. The weight we know 3m times acceleration a, we know that 1 over third uh, g, or g over 3. So then t equal 3mg minus uh, mg, because 3 to 3 cancel out. T equal 2mg. So we can find the tension. And now one more equation is remaining for particle P. If equal ma to upward, then two forces T and kmg. So T minus kmg equal, the weight is km, equal times acceleration is g over 3. So now T also we know that the only unknown is k, we can find k. So 2mg minus kmg equal kmg over 3. So 2mg equal kmg plus kmg over 3. So this is going to be 2mg equal 4 kmg over 3. So then m to m cancel out, g to g cancel out, and this is going to be k is 6 over 4, mean 3 over 2, which is 1.5. So k value we found out 1.5. Sometime you may do this one first and this one second. If you put this one first, and then you will see that the tension is you don't know the tension. Then you have to uh, put F equal ma to other one. So I did it because I see that this has to be done first and then this one second. But if you mix those two together, so then my advice is always write two equation. For example, when you put particle P, assume that you will get this one first, and then you think, how I'm going to find K, because I don't know T. So you don't need to think like that. Simply put the other one and find the answers. Part C, state how you have used the information of the police smooth. When police smooth, mean no friction. Then acceleration of both particle is same. So I'm going to put some other wordings here. Acceleration of both particle which are connected by inextensible wire is same. Why? Because to have a constant acceleration, same acceleration, there are two things depend on. One is the smooth pulley, and if this um, string is inextensible, then it also violate this the acceleration equality. If I put into a graph, smooth pulley, inextensible wire, okay, pulley, wire or string, and acceleration. Pulley is smooth, the string is extensible, then acceleration not same. If pulley is rough, this is inextensible, this is extensible, this is inextensible, then acceleration is same, not same. So here is smooth and inextensible, then acceleration is same. So what is smooth? In other way, it is a one of requirement of to become acceleration of same two particles same. Now in the next part, as usual, this will come and hit this cube, the ground, uh, and it will travel 1.8 second. So 1.8 second, not meter distance, travel from here to here, this distance. So 1.87 and hit the ground. At the time of, assume this, the travel length distance is A, let's say S1, then this particle also move S1 distance upward. And at the time when it strike the ground, the tension becomes zero. Now we work the previous sum also something like that. And then what will happen? This P particle start flying under gravity. So it is moving like this. And then it will stop somewhere. So this distance will take S2 as well. So I draw again. So this is the S1 distance. This is the initial position. So it will move up to S1, the same distance. And then this is freely move S2 distance. So you can see that this uh, string is something like this. In the picture, in that 2, this particle in actually in the same distance. So I am going to draw as in the same distance, 1.5 meter. So it doesn't affect anything so far. So then this distance, let's say S1, so this is going to be the S1 distance. This is S1 and this is S1 as usual, and then this is S1, this distance. So from the, so this is the initial position, both are there. So then from initial position, P particle move S1 and another S2. So from the initial position, greatest height is S1 plus S2. From the plane is here. From the plane, greatest height is, so I have to add this one again. So S1 plus S2. So because from the plane, initially it was with S1 height from the above, and on top of that S1, it will move S1 and another S2, this one. Now For q particle, so we want to consider this journey. For q particle, u is 0 when it's starting. In this starting from rest, it was here and it's come down. So u equals 0. T is given 1 point s, and we need to find s distance. So s equal a also we know now, that is g over 3. S equal ut plus half at square. So s equal u is 0 times 1.8 plus half times a is g divided by 3 and t is 1.8 square. Then we can find this distance. Actually we take as s1, this distance s1. So s1 equal 0.454 g. Now we know that s1 equals 0.54 g. Now we need to find this distance s2. So we know that v is 0 and initial speed we don't know that, and it's moving under gravitational force. Acceleration we know. Now we want to find this v, starting velocity. So let's say this u is equal to hitting velocity here. When the time it strike, the same velocity the particle p has upward. So then we want to find the velocity of this particle when it strikes. So for this one, we have to use v square equal u square plus 2as. Let's put it downward. So v square equal u square. So initial speed is 0 plus 2 times a. We know that is g over 3. And s we found out that is going to be 0.54 g. Then we can get v square 0.36 g square. Now we'll consider we need to find s2. So this is for particle p. Now we'll consider particle q. This is for particle q. For particle p, v square equal u square plus 2as to upward. So now we know that starting velocity v square equals 0 and starting velocity is u square equal to this one. So this hitting velocity is equal to moving p to this direction. So this is going to be 0.6 g square plus 2 times a. Now it is going under gravitational. So gravitational force is g downward. So this is minus g, and this distance is s2. So s2 is 0.36 g square divided by 2g. This is going to be 0.18 g. So the particle was here, then it is moved to s1, that is 0.54 g, and then under gravitational it's moved up, that is 0.18 g, and from the initial height for particle and this distance we found out that is 0.5 g as s1, same. Hence the total greatest height from the plane s1 plus s1 Now 2s1 plus s2 equal 2 times 0.54 plus s2 0.18. So this is g, and this is 1.26 g. So finally from here to here journey, the acceleration is g over 3. From here to upper journey acceleration is g um, under acceleration, so that is minus g for upward. So question number 3. So this is A particle and this is B particle. So it is 3g 3 kilograms or 3g weight. So this is the tension as this pulley is smooth and the string is inextensible, and this is mg, this is given mg, and so it's going this way or this way, which direction? So it is given that m greater than 3, so then it is m is more heavier, so it is coming like this. The acceleration should be here, and so it is going upward a, downward a, and this height is given 2.5, and we need to find the acceleration. Okay, we'll see first of all, as usual, we'll put F equal MA. I'm not following the order of this ABC. I'll just write the equation F equal MA to upward for particle B. Then you will get T minus 3G equal 3 times A. Then F equal MA to particle A. Then we get mg minus t equal m times downward a. So now how many unknowns here? 1, 2, 3. We don't know m, so then two equation we can't solve to find t a or mg. Then there should be something more. Then we need three equation to solve. So they have given some extra data, 2.5 distance, and also they tell that it will take 1.25 seconds to when after its release. So u equals 0 when it is released, 1.2 second it takes. Then we have s is 1.25, 2.5 meter, s is 2.5 meter, and a we don't know that. Okay, we'll leave as u we know that is 0, and t we know that that is 1.25 second, and s equal ut plus half at square when you put downward. So s is 2.5 and u is 0 and half. A is what is the a value? A we don't know, and t is square 1.25 square. Then a equal 2.5 times 2 divided by 1.25 square. So we can find a. Then we know a. We can substitute here. We can find tension, and then we substitute a here, tension, and a. We can find the m value. So those are the setup we can see. So a is going to be, so 3.2 m is minus 2. So this is 3.2 m is upward and downward. Now, so this is the part 1 of the question A. Part B, we need to find the tension. So we can find the tension from here. Let's say this is 2 from 1. T equal 3g plus 3a. So 3g plus 3 times a is 3.2. So this value, this is g is 9.8. So these 3 times 9.8 times 3 times 3.2. So this is, you will get 39 Newton. Now we want to find M. So M is from 2, from this one, mg minus t equal ma. So I will bring mg minus ma equal t. When I take m out, g minus a equal t. So m equal t minus ga. So this is easy. Tension we know 39. 39, G we know 9.8, then A is 3.2. So 39 divided by, this is going to be 8.6936. So divide by 6.6. So this is equal to 65 over 11 kg. So next part is find the time between the instant that A strikes the ground and the instant when the string become taut again. So it will come and hit here. So when it's come, when it's A hit, it will go 2.5 up. So this will also go 2.5. So I will bring that length here. So this is 2.5. So the aim length, it will go up to here 2.5. Now this is in here. Right? Then after that, it will start moving freely, this one, under gravity, and go to 0, and then again it is coming back. So it go up to somewhere here, and then again come back. So they want to know this time going up and coming down. So going up is equal to the ascending time is equal to descending time. So if we find ascending time, we can double that time. So for that, we have to use, let's say v equal u plus at, then we need to know v. So this v mean, start in u mean the hitting speed v here. So then we have to use as usual v square plus u square 2as to find the speed. So we consider particle A. To this word we will put v square plus u square plus 2as. So 18 speed is v square. U square, it is initially at rest, and then 2 times it's not coming under gravity. Gravitational acceleration, we found out A value is somewhere. A is 3.2, and S is, we know, that is 2.5. So v square is going to be, so this is 16, then v equal square root 16, so 4. So this is hitting speed is 4 ms minus 1. Then this is starting moving up, velocity is 4 ms minus 1. Then for particle A, for particle A, v equal u plus at upward. Then v is 0 at here. So this is half of the journey. U is upward. We know that that is 4 ms minus 1. uh, and A is minus G and T we need to find. So 0 equal 4 plus minus G times T. So T equal 4 divided by G. That is 4 divided by 9.8. So we will get 20 over 49. So it will take 20 over 49 to go up and 20 over 49 to come down. So total is uh, part D, question part D, 2t equals, or this is actually D, 2t equal 2 times 20, 49, 40 over 49 second it take. Uh, Again it's come to out. Question number 4, there is a table, and on this table pulley is fixed and two mass is on the table. One mass in the table, another one is hanging like this. So this is A and this is B, and this weight is given as 5. So the weight is going to be 5 kg. 5 kg. This mass weight is given as 3. So that there is a 3g, not kg. 5g and 3g. And since this is a smooth pulley and the string is extensible, there is a tension and there is a tension T and T. That's how we mark because of the pulley. And there is, this is, since this is not a smooth, so there is a restriction force. That force is 24.5 Newton. And so there is a R, that is normal reaction. Now this system release from the rest, so it is moving downward. So particle B is moving downward with A acceleration. So same acceleration as this particle, but it is direction is this one A. Now we need to find the acceleration, tension. So let's consider now particle B. For particle B, F equal ma downward, then two forces, 3g minus tension the other one. M is we know 3 kilogram and A we don't know, that is first equation. For particle A, F equal ma to this word. It's not 2 yet. Then there are two forces, tension and 24.5. This friction force T minus 24.5 equal mass, we know that 5 and A. So this is the 2. So two unknowns, two equations. So we can solve this one and we can find so when we add 1 plus 2, T to T cancel out, 3G minus 24.5 equal 8A. So this is 3 times 9.8, G value is 9.8. So this is going to be 29.4 minus 5 equal 8A. 4.9 equal 8A. A equal 4.9 divided by 8. So this is 0.6125. And then we can find From 1 or 2 we can use any. Let's take from 2, t equal 24.5 plus 5a, t equal 24 plus 5 times 5, a we found out 6.125. So t equal 27.5625. Part D, magnitude of the force exerted on the pulley by the string. So then we have to consider this system. We can see that it is here T and this one here T. So we can see that two forces. So the resultant force somewhere here. So we'll consider this one. This is T and this is T. So both have same. So you can come from any direction. So this is. I will take this as angle is theta, and this is going to be R resultant force. If this is T, this is T, so then you can come like this. T is R square, sorry, R is T square plus T square root. So 2 T square is square root. It means 2 square root 2 T. So we know the tension. So square root 2 times 27.5625. So you will get this one as 38.979 Newton. So approximately you can write 39 Newton. And the angle tan theta equal T divided by T, which is 1. So theta equal tan inverse 1, which is 45. So this is 45 and this is 45 because of that. Question number 5. I can see that this picture, this is given a box P, a 2.5 kg rest on a rough horizontal planes. Okay, this is 2.5 kilograms, so weight is N, as a resultant force R, and this is rough horizontal plane. It means there is a friction force. It is given as K, and so this is particle. There's a particle that is 1.5 kilograms, so the weight is 1.5 g, and it is hanging. The tension, there should be a tension then. So T as pulley is smooth and the string is inextensible. Then we know that standard. I didn't read the other part. So F equal ma, we can put F equal ma to particle. What is their name for this particle? This is Q and this is P. So particle Q, so it is downward. So it is moving so there is no some exit if it's not moving downward. A F. When we consider this particle, there are two forces, 1.5 g minus T equal mass is 1.5 times A, that is the first equation, and the second equation F equal ma to this direction for particle P. So then I can see that two forces there, T minus K equal M is 2.5, and this is moving to this direction with the same A. So this is the standard 2. Now how many unknowns? 1, 2, 3 unknowns. Now there should be another data to find k. Um, the system is released from the rest with the start the string dot after L is q descend distance of 0.8 with 0.75. It means okay, so this is descending uh, 0.8 distance with 0.75 second. 0.8 distance with 0. So now from here the only possibility is we can't find tension from here, and we can find k this friction from this one. The only possibility is the acceleration. So we equal, so s is given 0.8, t is given 0.75, then s equal ut plus half at square. So then we can find a. So s is given 0.8, u we know that starting at rest, so u equals 0. 0 times t is 0.75 times half a times 0.75 square. Um, so a equal 2 times 0.8 divided by 775 square. So that is going to be 2.844. So like ms minus 2. Now when we substitute a value to here, we can find tension, and tension and a substitute, we can find k. That's the standard sum. So from 1, t equal t to this side, so 1.5, both are 1.5, a to this side, so this is g minus a. So 1.5 times 9.8 minus 2.844. So tension is going to be 10.4 approximately, and from 2, k equal t minus 2.5 a. So t is 10.44 minus 2.5, a is 2.844, then k we will get as 3 point approximately 3.3 Newton. Part B, state how you calculation you have used the information that the string is inextensible. If it is inextensible, the tension in all parts are of it is same.